2e, multiplication and division of decimal numbers. Now, multiplication and division of decimal numbers is very similar to multiplication and division of whole numbers. We just have this decimal point to play with. So I'm just going to go through some examples and show you the process and point out what happens with the decimal, because you're really going to divide just like you did with whole numbers. The real question is going to be, where does the decimal go? And hopefully I'll be able to show you some ways to be able to get that decimal in the right place every single time. So let's start with multiplying decimals. So what if I have 3.57 times 8.2? Now, when we're multiplying decimals, we multiply just the same way as we did with whole numbers. And if you remember when we started into multiplication, I made a comment that you're always just going to make sure your rightmost digits line up. We're not dealing with lining up place values. So when I multiply this, I'm going to do 3.57 times 8.2. You can see I'm ignoring the place values. I'm not lining up the tenths place and the ones place. What I'm doing is I'm lining up the rightmost digit. And the reason I'm doing that is because with multiplication, it's not the alignment that matters, it's counting. And so by setting it up so the rightmost digit matches up, I'm actually going to save myself a little bit of work and make it a little cleaner. So I'm going to multiply this, and I can just ignore these decimals and points and multiply it just like I would if I had 357 times 82. So I'm going to go 2 times 7 is 14, carry the 1. 2 times 5 is 10, plus 1 is 11, carry the 1. 2 times 3 is 6, plus 1 is 7. And then I'm going to get rid of those. I'm moving over a place, so I'm going to put a 0 here. 8 times 7 is 56. Carry the 5. 8 times 5 is 40, plus 5 is 45. Carry the 4. 8 times 3 is 24, plus 4 is 28. And I'm going to add, just like I did in regular multiplication. 4 plus 0 is 4. 1 plus 6 is 7. 7 plus 5 is 12. Carry the 1. 1 plus 8 is 9. And 2. And now is where I worry about the decimal point. Notice all the way through, I didn't worry about the decimal point. Now I'm going to look at it and I can say, how many decimal places are there in my product? Look at my factors. I have 1 decimal place, 2 decimal places, 3 decimal places, right? I've got 2 in the first factor and I've got 1 in the second factor. It gives me a total of 3 decimal places. That's all I need to know. I am going to have 1, 2, 3 decimal places, which is going to put my decimal point right there. 29.274. Well, let's use a little sanity check here and say, does that make sense? Well, easy sanity check. Remember that rounding thing that we did? 3.57, if I round that to the nearest whole number, so to the ones place, that's 4. 8.2 rounded to the ones place is 8. 4 times 8 is 32. Compare that 32 to the 29. Am I in the ballpark or am I off by a lot? And when I say am I off by a lot, meaning am I off by a factor of 10 or more, such as if I came out with 292.74 compared to 32, that's off by a lot. 29.274 and 32, no, I'm right where I'm supposed to be. 29, 32, I'm in the right area. If I put the decimal point over here, I'd be 292 versus 32, not even close. If the decimal point ended up here, I'd have 2.92, not even close. So a quick comparison says, yes, this does work. This number is approximately or near to 32, so it put my decimal point in the right place. So that's our method, is multiply just as you would normally, and then just count your decimal places, and that's what's going to be your final decimal place. It's that simple. Let's do another one. I just want you to realize it's not as painful as you would think. $18.5 divided by 3.621. So that's right, I'm just jumping in the deep end. Let's get some big number here and deal with it, right? 18.5 divided by 3.621. Why did I put division? We're dealing with multiplication. 18.5 times 3.621. Just goes to show, anybody can make a mistake. It's okay to make mistakes. We just want to be able to recognize them and correct them as necessary. So 18.5 times 3.621. Well, we're going to multiply. 18.5 times 3.621. Now, I'm going to point out something here that I did not point out with our standard multiplication, and that is multiplication, the order that you multiply in doesn't matter. 3 times 2 is 6, 2 times 3 is 6. That's called the commutative property of multiplication. Same thing with addition. 3 plus 2 is 5, 2 plus 3 is 5. Doesn't matter which order you add in, doesn't matter which order you multiply in. But sometimes it's easier to multiply one way than the other. So I look at this and I go, yeah, that's what it says there, but in my opinion, it's easier to multiply it as 3.621 times 18.5. Because if you remember the process for multiplication, we're going to multiply the first number through all of them, the second number through all of them, the third number through all of them. We're going to keep working across. So this way we have to do that 4 times. In this way we'll only have to do it 3 times. So my preference is put the number with less digits on the bottom. It'll come out the same either way, and we'll do it both ways just to make sure that I'm not lying to you. Okay, so we'll start with this one. 1 times 5 is 5. 1 times 8 is 8. 1 times 1 is 1. Okay, put a 0 here, come over to 2. 2 times 5 is 10, carry the 1. 2 times 8 is 16, plus 1 is 17, carry the 1. 2 times 1 is 2, plus 1 is 3. Get rid of those carries, give myself 2 zeros so I can get to the 6. 6 times 5 is 30, carry the 3. 6 times 8 is 48, plus 3 is 51, carry the 5. 6 times 1 is 6, plus 5 is 11. Get rid of those carries, and now I want to get over to that 3 there, so I'm going to put 3 zeros in here. 3 times 5 is 15, carry the 1. 3 times 8 is 24, plus 1 is 25, carry the 2. 3 times 1 is 3, plus 2 is 5. And now I've gone all the way through. I'm just going to get rid of those carries out of habit. And I add it up. 5, 8, 1 plus 7 is 8, 3 plus 1 is 4, plus 5 is 9, 1 plus 5 is 6, 1 plus 5 is 6, and then I count my decimal places. I've got 1, 2, 3, 4 decimal places. So I'm going to have 1, 2, 3, 4 decimal places. So 18.5 times 3.621 is equal to 66.9885, according to this. Now I claim I can do the same thing over here and maybe make my life a little bit easier as I do it. So let's see. 5 times 1 is 5. 5 times 2 is 10, carry the 1. 5 times 6 is 30, plus 1 is 31, carry the 3. 5 times 3 is 15, plus 3 is 18. Put my 0 in there. 8 times, get rid of these. 8 times 1 is 8. 8 times 2 is 16, carry the 1. 8 times 6, 48 plus 1, 49. Carry the 4. 8 times 3, 24, plus 4 is 28. Get rid of the carries. Move over 2 places, so now I'm lined up with the 1. 1 times 1 is 1, 1 times 2 is 2, 1 times 6 is 6, 1 times 3 is 3. And if you haven't realized by now, anytime you multiply a number by 1, you get that number back. So I've worked my way through, and I add. And I make sure that I've got things in the right columns here. So I've got 5, 0 plus 8 plus 0 is 8, 1 plus 6 plus 1. So please be careful and make sure you line up your columns. I'm busy trying to work on this whiteboard from the side, and my columns kind of got a little sloppy here. We have 0, 8, and 0 gives me 8. 1, 6, and 1 gives me 8. 8, 9, and 2 gives me 8 plus 9 is 17, plus 2 is 19. Carry 1. 1 plus 1 plus 8 is 10, plus 6 is 16. Carry 1. 1 plus 2 plus 3 is 6. And I have 1, 2, 3, 4. 1, 2, 3, 4. And I get 66.9885. So we see that it does work either way. We also see that you have to be really careful to keep your columns organized, because you can see here that what happened was my 0 in this first column got messed up. It was sitting in the wrong spot, so I had to line other things. It really should have been aligned like that, so it would show up correctly, and that was a carry. So just to, that was a carry. So that's how it really should have been aligned. Okay, so that's multiplication of decimals. There's nothing more complicated about it. I could add a bunch of zeros on the end, but that's just going to make zeros. So if you did have something like 18.5000 times 3.621, we should realize that those zeros are unnecessary, so I could still write it as times 18.5 instead of putting all those zeros in the way. So multiplication of decimals, that's the way it works. But what about division of decimals? This is where it gets a little more complicated. Not a lot more complicated, but just a little more complicated. What if I have, well, I'm going to start with actually division of whole numbers that yields a decimal as the result, so we can see the process. So what if I have 16 divided by 7? 16 divided by 7. I can tell you from experience it's going to end up in a large repeating decimal. But we're going to get the process here. Okay, so 16 divided by 7. 16 divided by 7. How many times does 7 go into 16? It goes in once. 1 times 7 is 7. Okay, what did I do? I'm thinking ahead of myself, and I made a mistake, because obviously 16 minus 7 is going to give me 9, which 7 divides into that. So let's go back to this and say, how many times does 7 go into 16? It goes in twice. 2 times 7 is 14. 16 minus 14 is 2. Well, that would be 2 remainder of 2, but we're not going to stop there. What we're going to do is we're going to say, well, 16 is the same as 16.00000, right? 16.00000, it's just 16. Those zeros aren't anything, they're unnecessary zeros. So can't I do this and say 0.0000? Well, if I do, then I'm going to put a decimal point right there. Wherever our decimal point is down here in the dividend, it's going to be the same spot above it in the quotient. So if that's the case, now I can keep going. I can pull down this 0. How many times does 7 go into 20? It goes in twice. 2 times 7 is 14. Subtract, we get 6. Bring down a 0. How many times does 7 go into 60? It goes in 8 times. 8 times 7 is 56. Subtract, we get 4. Bring down the 0. How many times does 7 go into 40? 5 times. 5 times 7 is 35. Subtract, we get 5. Bring down the 0. How many times does 7 go into 50? It goes in 7 times. 7 times 7 is 49. Subtract, we get 1. Well, I've used my 4 zeros there, so I'm going to give myself some more. Okay? So, bring down a 0. How many times does 7 go into 10? Once. 1 times 7 is 7, so we're going to subtract and we get 3. Bring down 0. How many times does 7 go into 30? 4 times. 4 times 7 is 28. We subtract, oops, and we get 2. Bring down the 0. But if we notice that 20 here is what we had right here, the 20, so we're actually in the point that that's going to become a 2, and then an 8, a 5, a 7, a 4. So we actually end up with a repeating decimal, 2.285714, and it's going to repeat. You keep dividing, you get a 285714, 285714, 285714, 285714, etc., etc., etc. So dividing, we can keep going and turn it into a decimal. That was not the cleanest example, but it does show us we can keep going into the decimal. And if you plug that into a calculator, especially if you have a Casio calculator or some of your cell phone calculators, if you turn it sideways to the scientific, it will give you that repeating decimal. It'll simplify, if you can convince it to simplify, to not just do this as a simplified fraction, it'll give you that repeating decimal. So let's look at dividing a decimal. What if I have 0.571 divided by 0.2? So I have a decimal divided by another decimal. Well, if I put that into long division, I have 0.571 divided by 0.2. Now, I'll tell you right now, we do not divide by hand with a decimal. I don't divide 0.2 into things. If I'm dividing by hand and doing long division, I divide by whole numbers. So what I'm going to do is, instead of taking 0.571 and dividing by 0.2, I'm going to turn this into a whole number. And how I do that is by moving that decimal point over to the right one place. So I'm going to move that over and call it 2. Since I did that here, I'm going to do the same thing inside, and I'm going to make that 5.71. So that's going to put my decimal point right here between the 5 and the 7. Now I'm going to divide by 2 instead of by a decimal. 2 goes into 0, it doesn't. 2 goes into 5, 2 times 2 is 4. Subtract, we get 1. Bring down the 7. 2 goes into 17, how many times? 8. 8 times 2 is 16. Subtract, we get 1. Bring down the 1, now we have 11. 2 goes into 11 5 times. 5 times 2 is 10. Subtract, we get 1. Well, I'm going to give myself some more zeros. Right on the right side of the decimal point, I can give myself as many zeros as I want. So bring that down, that's 10. 2 goes into 10. 5 times. 5 times 2 is 10. 0, and we are done. So 0.571 divided by 0.2 gives us 2.855. So if we're dividing by a decimal, what we're going to do is we're going to move the decimal point over however many places necessary to turn it into a whole number. And we're going to do the same, however many places we moved it to the divisor, we're going to do the same thing to the dividend. Let's do another example. 7.6 divided by 0.005. So 7.6 divided by 0.05. So we've got 7.6 divided by 0.005. Well, we're not going to divide by 0.005. We want to divide by a whole number. So we're going to bring that over 1, 2, 3 places. So we're going to bring this decimal point over 1, 2, 3 places. Well, first of all, that means we're going to put some zeros in there. I'm going to extend this, and I'm going to put my decimal point right there. I moved this one over 3 places to get it to be a whole number. I'm going to move this one over 3 places to get it to a whole number. How many times does 5 go into 7? Once. 1 times 5 is 5. Subtract, we get 2. Bring down the 6. How many times does 5 go into 26? 5. 5 times 5 is 25. Subtract, we get 1. Bring down the 0. How many times does 5 go into 10? Twice. 2 times 5 is 10. Subtract, we get 0. And here I'm going to point something out to you. I'm going to help you avoid a common mistake. We got to the point where there's nothing left here, and there's only zeros here. But we still have another place, the ones place, before we get to the decimal point. So because of that, I still need to bring down that 0 and say, how many times does 5 go into 0? 0 divided by 5. 0 divided by any number gives you 0. So we do have to fill that one extra place in there to get us down to the decimal point. So be careful of that and be aware of that. That is a very common mistake, is for people to lose that 0 and say it's 152. But it's not, it's 1,520. So all we did is we moved the decimal point over so that we end up with a whole number for the divisor, and we move the decimal place over for the dividend, the same number of places, giving us our final decimal place value. So that's what we're looking at for dividing decimals. Now I want to give you one little side trick which comes from this, that it's not necessarily dividing decimals, but the opposite of dividing a large number followed by a bunch of zeros. What if I have 72 divided by 4,000? That's 72 divided by 4,000. Well, that does not look pretty to me. That does not look fun or easy. But I can use a very similar trick to what we did with dividing decimals. But what I'm going to do is, notice that if I want to turn, I can get rid of these zeros if I can turn this into a 4, right? If I move the decimal point over 3 places to the left, I'm dividing by 4. 4 is easy to divide by. 4,000, not so much. But 4 is easy to divide by. I'll have to do the same thing here, so I'm going to rewrite this just to give myself a little more space and say 4,000 divided into 72. Just giving myself some extra playroom, because what I'm going to do now is I'm going to go, 1, 2, 3, Now I'm dividing by 4. Here's the decimal point, right? I'm going to go 1, 2, 3. And so now my decimal point is here. So I'm going to need this other 0 there. Notice what I did. When we were dividing by a decimal, we moved it to the right enough places to turn it into a whole number. Now I'm dividing by a large number. I can move over to get past all these zeros. However many places I move over to do that, and let me just make sure that's more visible that I had to do that, do the same thing in the dividend and get myself ready to do my division. And I could even put my 0 here because I like to have a 0 before a decimal. So now I'm divided by 4, so I can rewrite this as 0.072 divided by 4. Note all I did was rewrote the same thing. I wrote that like this. Then I said, hey, I want more space so I can move my decimal point, so I gave myself some space, so I just rewrote it. And now since I've got it 0.072 divided by 4, I just wrote it as 0.072 divided by 4. Put my decimal point in there. And I can go 4 goes into 0, 0 times. I'm not going to write that down because obviously 0 goes into 0, 0 times. 0 goes in 4. Sorry, I said 0 goes into 0. 4 goes into 0, 0 times. 4 goes into 0, 0 times. 4 goes into 7 once. 1 times 4 is 4. Subtract and I get 3. Bring down the 2. 4 goes into 32, 8 times. 8 times 4 is 32. Subtract, and we get 0. So 72 divided by 4,000 is 0.018. So it's a little trick that we can use to be able to divide large numbers into something if they're large numbers with a bunch of zeros there. So we can move that decimal point over just like we did playing with decimals. So, like I said, a little side trick. Another thing that I'd like to cover is, what if you're multiplying or dividing by a multiple of 10? So a tenth, a hundredth, a thousandth, a 10,000th. Or if you're multiplying by 10, 100, 1,000, 10,000, anything of that sort. How does that affect things? Well, if you're multiplying, so I'm going to say if you multiply by 10, 100, 1,000, 10,000, or if you multiply by 1/10, 100th, 1,000th, just to give us some examples here, what happens? If you multiply by 10, all you're going to do is move the decimal point one place to the right. So decimal point is going to move to the right one place value. Decimal point is going to move to the right 2 places. Move to the right 3 places. Move to the right 4 places. Notice the decimal point is going to move to the right by the same number of places as you have zeros. 1 0 moves to the right by 1. 2 zeros moves to the right by 2. 3 zeros moves to the right by 3. 4 zeros moves to the right by 4. If you're multiplying by 1/10, 100th, 1,000th, it's going to move to the left by 1. Move to the left by 2. Move to the left by 3. And notice again, that's the number of the place or number of decimal places to the right of the decimal. So 1 decimal place, you're going to move to the left by 1. 2 decimal places move to the left by 2. 3 decimal places move to the left by 3. And realize this only works when you're dealing with 10, 100, 1,000, 10,000, 100,000, right? 1 followed by zeros, or decimal point followed by zeros and 1. Does not work if you're dealing with 20, 200, 2,000. Doesn't work anymore. Okay, so this is very specific. So let's show an example for each of these. Okay? So an example, 5 times 10. 5 times 10, this says since you're multiplying by 10, move the decimal place one place to the right. So 5 becomes 50. We add that 0 to it. And that's a nice thing too. You can even look at it as not necessarily moving to the right by 1, but adding that many zeros to it. 5 times 100, 500. You just follow it by 2 zeros. 5 times 1,000, 5,000. You move it to the right by 3 places, or you add those 3 zeros. 5 times 10,000, 50,000. Add those 4 zeros, or move it to the right by 4 places. Move it to the right place to the left. 5 times 0.1, move the decimal place one place to the left, you end up with 0.5. 5 times 0.01, or 100th, move to the left by 2 places, boom, boom, 0.05. 5 times 1,000, 0.001, gives you 5 thousandths, 0.005. So you move it, the decimal place to the left 3 times. So that's a little trick that you may use when you're multiplying by multiples of 10. 10, 100, 1,000, 10,000, 10th, 100th, 1,000th, 10,000th, etc. Well, how does that differ if we're dealing with division? So I'm going to take this out, and we can get rid of these. Get rid of those, and say, okay, if we divide by these values, what happens to that decimal point? If we're dividing by 10, then it's going to move it to the left by 1. Dividing by 100, move it to the left by 2. Dividing by 1,000, move it to the left by 3. By 10,000, move it to the left by 4. If we're dividing by 1/10, it's going to move it to the right by 1. If we're dividing by 100th, it's going to move it to the right by 2. If we're dividing by 1,000th, it's going to move it to the right by 3. So if we turn these into divisions, divided by, then what we have, 5 divided by 10 is 0.5. We move that decimal place one place to the left. That decimal point one place to the left. 5 divided by 100, 0.05. Divided by 1,000, 0.005. Divided by 10,000, 0.0005. 5 divided by 0.1, that's going to move it to the right one in place. So divided by 0.1 gives us 50. Divided by 0.01, 500. Divided by 0.001, 5,000. So again, we can see what happens with it. Now this can be handy. One, it can be handy if we think of scientific notation, which we already covered, right? That 10 to the factor, what's going on here, right? 10 is 10 to the 1. 100 is 10 to the 2, 10 to the 3, 10 to the 4, 10 to the negative 1, 10 to the negative 2, 10 to the negative 3. It's scientific notation. Okay? Well, that's how we use it. So that's part of this, and you can see that these things are tying together. Okay, there's a few more things I want to cover in this. First of all, a little bit of common sense or sanity check material. If you are multiplying by a number greater than 1, so if you're taking a number and multiplying it by a number that's greater than 1, you're going to get a larger result. So anytime you're taking some number and multiplying it by a number greater than 1, you need to get a larger result. So if your number you get as a result is not larger, you did something wrong. If you multiply by a number between 0 and 1, you'll get a smaller result. If you divide by a number greater than 1, you're going to get a smaller result. And if you divide by a number between 0 and 1, you're going to get a larger result. So these are just some pieces that will help to pull things together and help you kind of look at it and go, well, wait a second. I took 0.572 times 64.3 and I came out with 743 point whatever. Now, looking at these rules that I just stated, you're taking 64.3 and you're multiplying it by a number smaller than 1. So your result has to be smaller than 64.3. It can't be something larger than 64.3. So you have to be able to look at that and say, that cannot be right. I made a mistake. And that's what I'm looking at here is, if you're multiplying by a number greater than 1, you've got to get a larger number. If you're multiplying by a number between 0 and 1, you've got to get a smaller number. If you're dividing by a large number, if you're dividing by something larger than 1, then it's going to make your result smaller. And if you divide by a number that's between 0 and 1, so a very small number, it's going to make your result bigger. Okay? So I just want to finish with 2 definitions. First is hypothesis. Now I know that you've already know that a hypothesis is an educated guess, because that's what they teach you in science, right? I want to make this a little more specific, and I want to say that it's an educated guess based on observed patterns. So meaning, you look at something and you see, hey, it tends to act in this way. And so you hypothesize that this is what it does, that it does act in that way. And it will always act in that way. So that's a hypothesis where you're making an educated guess based on what you've observed. So like I said with these things, you multiply by numbers greater than 1 and you find out, hey, my numbers just are always bigger when I multiply by that. So now that I've done that and shown, yes, that does work. Every time I multiply by a number greater than 1, I get a larger result. Now you can make a theorem which is a mathematical fact that is proven by other mathematical facts. So basically now I can go, aha, I see that whenever I multiply by a number larger than 1, I get a larger result. Therefore, I have that theorem, and that's something that I can actually use. It's no longer a hypothesis that, hey, maybe this is the case. Now it's a matter of theorem, this is the way it is, and this is the way it will always be. So that is multiplication and division of decimals.